This is my last video on this worksheet. It's on power. So let's go to the bottom. It's the last page, and here it is. Power is the rate of doing work or expending energy, which means this a powerful elevator will get you to the top floor quicker, and a powerful heater will heat your room quicker. Heat will pour out of a powerful heater quicker than it'll pour out of a cheap heater. Power is W over T. Of course, since W equals F times D, it's also FD over T. And since D over T is V, you can also find power by multiplying the force times the velocity. Like everything else, it's a scalar. And let's do a problem on power. You've got a car, and it goes some rest where VI equals 0 to VF equals 0 in 7.4 seconds. What is the power? Now, what is this car doing? It's changing its kinetic energy. So if I want to find the work that was done by the car, getting back to what we've been doing recently, the work is equal to the change in kinetic energy, because when work is done on or by a system, the system's energy changes. This car changed kinetic energy, so if I want to find the work it did, it's equal to the change in kinetic energy. But before we do anything like this, before we do the you know difference between the kinetic energy before and after, we've got to change this 95 kilometers per hour into meters per second by converting. So I make some conversion ratios and say, well, a kilometer is 1,000 meters, and that's of course one. So the kilometers cancel out, and then hour. Put an hour up top because the hour is on the bottom. Whatever I want to get rid of, I put on the opposite side. That is 3,600 seconds is an hour. 3,600 seconds. 60 minutes for an hour, and 60 seconds in a minute. That turns out to be, you can see down here, I've already worked it out. Turns out to be that. And so the initial velocity is 0 because it starts from rest. So the work is 1/2 the m, 1440 kg, um, times the v squared, which is, we said it's 2.638 repeating, and all of that squared. And you have to put, actually, if I want to find power, you got to put all of that work, all that change in energy over 7.4 seconds, which is given. Because remember, power is the rate at which work is being done. How did I find the work? I found the change in kinetic energy. So there you go. Turns out to be this is the power. And the units for power, I didn't say this already, are watts. That's the metric unit for power, watts. So there you go. So once again, this is a car. What was its power? It's W over T. Well, what's the W? Well, it changed speed, so it changed kinetic energy. The work that it did is exactly equal to the change in kinetic energy. I converted the kilometers per hour to meters per second, and I used 1/2 mv squared. Football player mass runs upstairs 6.6 seconds, and the stairs are 14 meters long at an angle of 32. So let's do a little sketch. It's always useful. Do a little sketch, and you have to. It says, "What's the output vertically?" So actually, that's where you have to. Since this one is going to be something new for you to see, the work, ready. The power is work over time. Now you can't do just F times D, because they want the work that's the vertical work. The vertical work, that means you've got to use sine, because you've got to deal with the vertical force that he applied. He applied a force of what? His weight. Every time he goes up the stairs, he's lifting his own weight. That's the work he's doing. But because you want the vertical work, you've got to use the sine of the angle. Anytime you see the vertical output, you use sine because sine is the vertical component times the distance, which is 140 meters, divided by t, which is 66 seconds. And so, what was his power? He was doing work lifting himself going up the stairs because it's his weight is 950 newtons multiplied by 10 times sine of the angle, which is 32. To make it into work, we have to do the distance, which is 140 meters. Actually, yeah, this is his dy. It's better to think of it this way. If you want to find his vertical work, what is his vertical displacement? Sine 30 times 140 is his dy. So there you go, all of that divided by t, which is 66 seconds. So output vertically is just accounting for the dy. That's the dy in the work. Sine 32 140, that was given, and that turns out to be this many watts. Toughest of them all. This is the toughest of them all. You've got a 1200 kilogram car. Its maximum power output is 120 horsepower, and of course that's not the unit we need, so we'll have to convert it. How steep of an incline? That's theta equals question mark. How steep? Uh, can it climb at a constant speed of 75 kilometers per hour if the frictional force is this? All right, constant speed. Right away, I know what to do with that. Constant speed. The net force is zero. So let's see, 120 maximum out. How steep uh, can it can this truck climb at that speed if the frictional force is 650? So let's make a little picture. And this is the car, and the car is going to have to apply some work this way. Friction acts this way. Some of the forces, now there's another force going down called mg sine theta. So if the net force is going to be zero, the force of the car has to, so the ups equal the downs. When we do this, ups equal the downs. If we're going to go at constant speed, the ups have to equal the downs. So what are the ups? Well, the force of the car. Okay. So the force of the car equals, that's the up. The two downs are mg sine theta plus the friction. If he's going to go up at constant speed, he has to apply a force that's equal to mg sine theta and the friction, which are the two forces going down. So now we find the force of the car. Okay, good. Now let's take care of some of these issues here, these conversions. We'll get back to this. 120 horsepower. We need watts. So 1 horsepower, HP, is 746 watts. So you'll always be given a conversion factor. You don't have to memorize this. This course is nothing about memorization. So I'm going to go down here. I've already multiplied it. 89,520 watts. So that's my power. So how does this work now? The power equation is W over T. So, oh, and one more thing too. I forgot this kilometers here. I've changed the kilometers. Let me do the conversion on that so you can see that what that looks like. Even though we've done it quite a bit. So you've got 75 kilometers per hour, and you know that 1 kilometer is 1,000 meters. So those cancel out, and 1 hour is 3,600 seconds, and it turns out to be this many. This, when you do the multiplication, you get this velocity. Now, what's the power equation? Well, it is W over T, but I don't use that. You know what I use? Because I have F for the car, I use F times V. So power is W over T, but remember, where do we get that? Well, work, just to derive it again, what's work? It's F times D over T. And we see that power is F, which we have, the F of the car, times V, which we have, is right there, is right here. So power, which we're given, is, 89,520 watts. That's the power. Power equals force. Force of the car is mg sine theta plus friction. In order to get up that hill at constant velocity, he has to apply that force. What's the velocity? Well, we actually have the velocity. The only thing we don't have is theta. This is what is the what is the angle of what's the maximum? Where it is look how steep? Question about how steep? That's a theta question. So let's substitute mg. Well, 1200 is the m, so mg is 12,000 newtons times the sine of that unknown angle, plus we're given the friction, it's up there is 650 newtons, times the velocity that we found down here, 20.83 meters per second. And now it is a very sloppy. I think I need to clean this up because it's really getting crowded down here. All right, let's clean this up just so it's 89,520 watts equals 12,000 newtons, the weight, times the sine of the angle that we don't know, plus 650 newtons is the friction, times the velocity, because the power is force times velocity. Now we divide both sides by this velocity. This over here by 20.83 meters per second, and we get 4,297.647 equals 12,000 newtons, sine of the angle we don't know, plus 650. Then you subtract, let's see if I can, let's scroll up a little bit. Oops. There we go. Let's scroll up a little bit. Oh, I ran out of room. Look, this is just a math problem, so I'm going to let you work on this yourself. You've got to subtract 650 from both sides. Subtract 650 from both sides. And you divide by 12,000, and you get sine of theta, which you divide by 12,000 is 0.303. And then you do the inverse sine of 0.303. You get about 18 degrees. Okay, so it's an algebra problem. You subtract the 650, you divide by 12,000, you get sine of theta is 0.303, and inverse sine is 18 degrees, and that is it.